Hey, welcome to Models and Agents, Episode 5 for March 2nd, 2026, your daily briefing on the AI models and agents that are changing everything. And no, not those kinds of models and agents. Let's get into it. FireRedTeam releases FireRed-OCR-2B, a 2B-parameter model tackling structural hallucinations in document parsing for tables and LaTeX. All right, that hook should have your attention if you've ever wrestled with AI mangling a table or spitting out nonsense LaTeX code. Today, we're unpacking a fresh wave of developments that could make your AI workflows a lot smoother, especially if you're dealing with documents, agents, or simulations. The big standout is this new model from FireRedTeam that's fixing some persistent headaches in vision language tasks, and we've got a bunch of arXiv papers dropping innovative multi-agent systems for everything from payments to urban planning and even detecting suicide ideation. Stick around because we'll break down why these matter for your daily builds, and I'll point you to what you should experiment with this week to see real gains in areas like healthcare workflows or simulation benchmarks. Let's jump into the top story because this one feels like a genuine step forward for anyone knee-deep in document-heavy AI work. FireRedTeam has just released FireRed-OCR-2B, a 2 billion parameter model that's laser-focused on solving what's known as structural hallucinations in document parsing. You know, those times when a large vision language model, or LVLM, looks at a scanned page with tables or LaTeX equations and just invents stuff, like jumbling the order of rows or fabricating elements that aren't there. This model uses something called gradient response prompt optimization, or GRPO, to treat the whole parsing job as one unified task. No more breaking it into separate stages like detecting layouts and then extracting text, which is where traditional LVLMs often trip up and produce disordered or made-up outputs. Technically, it's a big improvement over models in families like Florence or Polygemma, which might require those multi-stage hacks. FireRed-OCR-2B preserves the order and syntax of complex structures way better, and it shines on benchmarks for things like tables and LaTeX without needing extra bells and whistles. According to MarkTech Post, it outperforms those traditional methods while keeping inference costs low, which is huge for developers. If you've been using something like Mini-CP-M-V for similar tasks, this is a specialized upgrade. It's got that focused edge on developer tools, reducing errors in automated extraction for code or scientific docs. Why does this matter to you? Well, imagine automating code reviews or pulling formulas from research papers without the AI hallucinating half the content. It's a game changer for software devs in data-heavy fields who've banged their heads against unreliable OCR. And since it's open source, you can grab it on Hugging Face and integrate it into your pipelines right away. Keep an eye on community fine-tunes for tweaking it to your domain, like customizing for medical records or legal docs. Looking ahead, this could expand into multimodal agents, maybe combining with tools like LangChain for full end-to-end document intelligence. If hallucinations have been your nemesis, this is one to test pronto. It feels like the kind of practical breakthrough that cuts through the hype. Shifting gears to model updates, we've got a few fresh ones that build on that theme of making AI more reliable and efficient. We already touched on FireRed-OCR-2B in the top story, but just to reiterate from MarkTech Post, it's this 2B-param model using GRPO to unify document digitization. It fixes those LVLM hallucinations for tables and LaTeX without multi-stage processing, outperforming traditional methods on benchmarks by keeping everything in order. Compared to smaller models like Mini-CP-M-V, it's got a specialized focus that reduces errors at low cost, perfect if you're building apps for parsing code or scientific documents. Next up, there's this intriguing paper on arXiv about enhancing Clip's robustness. Clip, if you're not familiar, is that foundational vision language model from OpenAI that aligns images and text for tasks like zero-shot classification. The new framework, called COLA, is training-free and uses optimal transport to improve adversarial robustness through cross-modality alignment. Basically, it filters out non-semantic noise and tightens up how image and text features match, boosting performance by 6.7% on tough ImageNet variants under attacks like PGD. That's better than some fine-tuned baselines, and it addresses weaknesses in models like Clip or even Flamingo. For you practitioners, this means more dependable VLMs in security-sensitive apps like content moderation or autonomous systems. Just note it needs augmented views to really shine, so if robustness is a pain point in your image text work, this could be a quick win without retraining everything. Rounding out the model news, another arXiv drop introduces a discriminative model for general semantic chunking built on Qwen 3 0.6b. This one's all about handling ultra-long documents for topic segmentation, supporting up to 13,000 token inputs and compressing representations with vector fusion. It outperforms generative LLMs by 2 orders of magnitude in speed, with better F1 scores on datasets like Wiki 727,000, and it's faster than Gina's Qwen 2 0.5B models too. If you're wrestling with massive texts in your RAG, retrieval augmented generation, pipelines, this is a practical upgrade over something like Llama for long context tasks. It's optimized for English Wikipedia-style data, so it fits right into knowledge base apps, but keep that in mind for non-English or diverse corpora. Overall, these updates point to a trend of specializing models for reliability, whether it's documents, robustness, or long-form processing, helping you build without as many gotchas. Now, let's talk agents and tools, because today's briefing is packed with systems that show how LLMs are powering real-world autonomy. First, there's HMASP, a hierarchical multi-agent system for payments from an arXiv paper. It uses LLMs in a setup with agents like a CPA and supervisor to handle end-to-end workflows, incorporating modular execution and secure data access via MCP. This is a first for agentic payments, going beyond static LLMs by coordinating multiple levels. Think handling approvals, verifications, and transactions seamlessly. It works with open or proprietary models like those from OpenAI or Claude, and the open source code lets you prototype financial agents today. Just grab an LLM API, and you can see how it streamlines things without heavy custom coding. If payments are in your wheelhouse, this could be a fun one to tinker with. On the graph side, Rudder embeds LLM agents into AWS DistDGL for adaptive prefetching and distributed GNN, graph neural network, training. Using in-context learning, it cuts communication overhead by 50% and boosts performance up to 91% over baselines, adapting to dynamic graphs better than static methods. It integrates nicely with frameworks like AutoGen, and you can test the GitHub repo on setups like Perlmutter for GraphML tasks. It's tailored to large-scale infra, so if you're on AWS and doing distributed training, this agent's smarts could save you serious time. We've also got a hierarchical agent framework for city editing on arXiv, using LLMs for dependency-aware modifications in GeoJSON formats. It handles urban geospatial tasks like renewal projects with iterative planning and error mitigation, outperforming baselines in efficiency and validity. This extends tools like LangGraph for spatial agents, and the code is ready for urban simulation projects. Great if you're into planning or GIS, though it assumes clean input data. Finally, RESP-Agent is an agentic system for respiratory diagnosis, with a Thinker A2CA module for multimodal sound generation and analysis on the new RESP 229,000 dataset. It uses LLMs to bridge data gaps and cut biases, outperforming baselines in scarce data scenarios and complementing frameworks like Crew AI for health AI. Check it out on GitHub for audio-text tasks. It's compute-heavy for fine-tuning, but exciting for diagnostic tool builders. Whew, just when you thought agents couldn't get more niche, they're popping up everywhere. I'm genuinely pumped about how these make complex tasks feel approachable. For the practical and community side, we're seeing some cool integrations that bridge AI with real-world simulations and tools. One arXiv position paper proposes hybrid constitutional architectures for social simulations, combining agent-based models, or ABMs, like Gamma or NetLogo with small language models and LLMs. It balances flexibility and transparency, fixing biases and scalability issues in benchmarks like Smallville. If you're a researcher in multi-agent systems, this solves common pain points. Start by experimenting with those NetLogo integrations. Just watch for undertraining risks in the LLMs. Then there's MicroBot, a mixed initiative system for human-robot dialogue from another arXiv update. It uses planners and affordance models to cut down human effort in collaborative tasks, outperforming plain LLM baselines in physical trials. This tackles manipulation with natural language, which is super useful for robotics devs integrating something like semantic kernel. Try the UT Austin demo for task planning. You'll need robot hardware for the full experience, but it's a step towards smoother human-AI teamwork. Last in this section, Site Audit is a new 1.3 million sample benchmark with a multi-agent pipeline for spotting hallucinated citations in scientific writing. It extracts claims and reasons to outperform standalone LLMs in accuracy, addressing risks in research and complementing RAG tools for verification. Grab the dataset for fine-tuning your own evaluators. It's domain agnostic but shines on academic texts. These community contributions are gold for solving everyday frustrations, like biased sims or dodgy citations, and they remind me why open source keeps this field moving so fast. Okay, if all this has you itching to build, here are some things to try this week. First, give FireRed-OCR-2B a spin via Hugging Face for parsing LaTeX docs in your code pipeline. It's a low-cost way to cut hallucinations compared to standard LLMs, and you might see immediate wins in accuracy. If you're on AWS, experiment with Rudder's LLM agents in dist-DGL for GNN training. It could slash your communication overhead in distributed setups. Integrate HMASP into a payment prototype using Claude or GPT APIs and see how those hierarchical agents handle real workflows without much custom coding. Test RESP agent on the RESP 229,000 dataset for health audio tasks. It's worth exploring if you're building diagnostic tools with multimodal LLMs. And compare Cola's robustness enhancements on Clip for your image text apps. It boosts adversarial defense without retraining, unlike fine-tuned alternatives. These are hands-on ways to level up your projects right now. On the horizon, watch for expansions of FireRed-OCR-2B to broader multimodal tasks, potentially integrating with agent frameworks like LangChain. Expect more arXiv follow-ups on hierarchical agents building on HMASP for domains beyond payments like logistics. Anticipate benchmarks evolving from Site Audit, possibly incorporating MCP for standardized LLM evaluation in research tools. And look out for real-world deployments of systems like MycoBot in collaborative robotics, with betas in frameworks like Microsoft AutoGen. Tomorrow, keep an eye on potential arXiv drops expanding hierarchical agents into logistics, building right off today's HMASP developments. That's Models and Agents for March 2nd, 2026. If you found this useful, share it with someone who's trying to keep up with all these changes, and subscribe so you don't miss tomorrow's update. The AI world moves fast. We'll help you keep up. See you tomorrow.